So, hi guys, my name is Kuldeep, and I wanted to discuss the time complexity analysis of merge sort. And if I get time, I will try to also write some loop invariants if possible. Okay, so merge sort is a sorting algorithm that uses the divide and conquer approach. That is, it divides the problem into smaller problems and then independently work on those smaller problems and then finally merge the two results. That is why it is called merge sort actually, because we divide the array into two parts, merge the two independent sorted parts. Okay, so let us first see how the merge algorithm works. Merge takes into sorted arrays and then it outputs a merged version of the array such that the result is sorted. For example, this example I have taken 14566 and 11268 are both sorted. And my aim is to achieve something, achieve the merged version of the two arrays such that the result is also sorted. Okay, so it is quite easy. It is quite intuitive actually. That what I can do is that I can keep two pointers. Initially, they will be at starting, and I will keep on comparing. And I will always take the smaller one because I want a result to be increasing order. So I like, for example, I will first be at the one position, like one and here also one. I will compare both ones, but since both are same, I will put it inside my result array. I will move this one step ahead because I have already checked one, but it is still here because it was not yet. It didn't yet went in the result array. So one and out of one and four, one is smaller one, so I will keep it here. I will put it inside my result. I will move ahead. Again, 4 and 1. 1 is smaller. So it will come down in the result array. And now this pointer will go to 2. Out of 2 and 4, 2 is smaller. So 2 will come down. And this will go to 6. And this will still be to 4. Out of 6 and 4, 4 is smaller. So 4 will come in the result. It will go again ahead. And now 5 and 6. 5 is smaller. So it will also come down. And this will also be at 6. So out of 6 and 6, both are same. So let's keep it there. Again, it will go ahead. And out of 8 and 6, 6 is smaller. And also one more thing, 8 should be also there. Okay. So this is how my merge will work. It is quite simple. It is quite intuitive. That I need to traverse both the arrays, check which one of them is smaller, keep it in my result array, move my pointer ahead because I no more need that. I need to check for the next element which one is smaller. So this is how the basic approach of merge is. So in order to find the time complexity of this merge, it is actually quite simple. There are simple while loops. That is, I am only traversing both the arrays only for only in one pass only. Like basically, although there are many passes like one, two, three, there may be three while loops. But if you carefully observe, then this while loop will only traverse the part up to minimum of the two arrays because there is an AND condition because of which I will only traverse the minimum of the two array sizes. And after that, if one of them is like larger than the other, then that particular part would have been left and that would be covered with these two while loops. So although it might seem that there are three while loops, but basically they are there because I always want to cover cover both the arrays completely. So this will work up to minimum of the two array sizes. Say array one is smaller. Array one is of smaller size, say only two elements, and array two is of four elements. So this will only work for two. This will only go for two iterations, and then I need to go for two more iterations in order to cover the array two, which was of four element size. Okay, so because of this, It is simple if we not even use that simple naive approach. It is still quite simple. Like initially, I will have a m plus n size. After that, I will now have one size less because I have moved one step ahead, and it will take us a linear time of order one time, and then I can work for m plus n minus one, and it will be p of m plus n minus two. And again, it will take one constant time. So in the same way, I can just add up all these things. So ultimately, what I will get is p of m plus n will be now I am always decreasing one here and corresponding to them a constant time will be there. So t of m plus n will be some constant time m plus n finally. And if you ask me for time complexity in big O notation, then it will be of order of minimum of um, yeah, pretty much that's it. Like order of, or you can say the maximum. Actually, both will work. Doesn't matter. Yeah, or you can simply say order of n plus n if you don't want to go into minimum and maximum. So this was about merge, right? Okay. So and for merge sort, what merge sort is doing, it was dividing my problem into two parts. So basically, let us say I have initially p of n, like I want to find the time complexity of n size. What I'm doing is that I'm dividing into two parts and p of n by two. Okay, so and I'm then merging. Merging also takes time, and merging is of the both arrays, so it will be n m plus n is basically n here. The part of merging we have already covered. The same thing goes for n by two. It will go now to p of n by four because now it will divide more into two, further into two. Plus it will have a n by two. Now suppose I substitute this t of n by 2 into t of n, the equation for t of n, and it will look something like this. 4 times 2 square times 4 plus 3. Yeah, and if you keep on doing this, you will see the pattern that it's like 2 raised to the power log n base 2 into t of 1, this is constant space, constant time, constant, plus 3 times, plus n times log of. Yeah. So the time complexity will be the heavier of the two. So it's end of. So that's how we find the time complexity of the two parts.